Parametric AI is working on a new tool to make it so that NPCs, the non-playable characters in video games, are much more realistic. And if you've seen Westworld, you know what I'm talking about. Their new model is meant to make the NPCs actually learn and then act more like humans, and it has an interplay between two different artificial intelligence models. Now, the environmental model is keeping track of where people are going, making predictions about what they're going to do and who they're going to interact with. So the soul module has more of a long-term memory for each of the NPCs and helps them make decisions. And the result of these two different AI models coming together is that the NPCs actually experience their own storylines. So when the actual gamer starts to interact with an NPC, it seems much more realistic and immersive. And then on top of that, they use something like ChatGPT, a large language model, so that the characters interact with you in a way that's unique each time. The Unreal Engine has now introduced Metahuman Animator, a new capability for metahumans which allows artificial intelligence to automatically generate the complex character details. And this system actually generates these high-quality animations in real time with nothing but an iPhone. And even, yes, this is a thing, tongue animation. It's just obvious when you think about it, but I've never thought about it before. So it actually knows where the tongue should be inside the mouth. The technology only requires a couple minutes to actually generate the rig on the face. They actually do it live during the demo. And the rig is basically figuring out anchor points on the face and then following those around on the image so that it can actually move the animated face in the same way that the real human face is moving. The face is now rigged up. Deep Motion's capture and animation tool uses artificial intelligence to analyze and interpret motion data. That means you can take video of you dancing, if you want to, and it can pull that data into a 3D environment, understand how you're moving, and then rig that, put that on an animated 3D character so it can follow your hands and do the exact same thing. And once you have all this data, you can use that in a 3D environment. So, a video game, or maybe in the future we'll have metaverse-style Zoom calls. All of that kind of stuff can be mapped to you or any character. And this kind of new artificial intelligence-based rigging model, these 3D extractions from 2D information, they save a ton of money for companies. Think about how complicated it is to make a sports game, like a basketball game. You bring in NBA players, you map them up, and you motion track the way that they move.
One, go!
That would usually include all sorts of tools like physics simulations, foot locking, slow motion handling, and face tracking. Throw all that to the side and just take it from the 2D information already captured. Luma Labs is known right now for creating a 3D scanning app you can use on your phone. But now they have another offering, which is called Luma Labs Imagine 3D. And if you're lucky enough to be past the waitlist, this is a tool right now that you can go in and prompt with text to get 3D objects. Now, I think this makes a lot of sense for Luma Labs to go in this direction because the way that their app worked is perfect for training a model like this. You actually took your phone and you went around an object 3 times, once from an elevated position, once from middle, and once from under. All that data tied into how the accelerometer in the phone was positioned, so they knew how much distance there was from the phone. So using a technology called NERF, they can actually extract out 3D information from those 2D photos. Plus, they also make a perfect mesh, so it gets a sense of what the color and the object looked like when it was scanned in, making it look like a really nice, realistic 3D object. NVIDIA just announced Magic 3D, which can generate 3D models from a text prompt, so think like Midjourney, but for 3D objects. Magic 3D employs a 2-stage method, first generating a rough model in low resolution, and then a second model that optimizes it for a higher resolution. So the model starts by generating 2D images, like Midjourney, but then it takes it and turns it into volumetric data, 3D information, using something called NERF, Neural Radiance Field, but the only thing that you need to know is that it just understands what 2D objects look like in photos and what they look like in 3D, and it's been trained on that data. So in the future, when it sees 2D models, especially a few 2D models that kind of connect to one another and give different angles, it can then extrapolate out that 3D information. Now, this isn't the only model that's attempted to do something like this. The previous top dog was Google's Dream Fusion, but NVIDIA says this works twice as fast. It doesn't just stop at generating, it can also do text editing on a 3D object. A team at Carnegie Mellon University came up with this awesome way to just take 2D label maps and turn them into 3D meshes. Like maybe another way to say a 2D label map would just be like a 5-year-old with a crayon. Look at this example. That is a crude looking car, but that is an awesome rendering. And that would be cool enough as it is. We've seen some stuff like it, but it's the 3D element that really impressed me. Think of how unusual that is, that you could take a child's drawing of a car, rotate it in 3D space, leaving those simple lines so fascinating. Check out this new demo from Unreal Engine. In this new video presentation, they show off an experimental new feature that's in Unreal Engine 5.2. Actually, not so much a feature as it is a suite of artificial intelligence tools working together. Now, the demonstration features the use of procedural content generation, which means that the algorithm is making all the small decisions. It's an abstraction layer where we can say to the artist, think about the environment from a macro scale. What's the character's experience supposed to be like? And go in there and just make the big changes. And all those little details that used to take up so much time can be procedurally generated, meaning it just automatically understands the lighting, the textures, and it puts things together in a realistic way. And that's a lot for the AI to actually automate. If you think about it, that includes things like lighting, wind, chaos physics simulations, real-time fluid simulations, and even the sounds that are supposed to echo and ricochet off the things around you. All of that is procedurally generated. When the truck drives under this fallen tree, it moves from something that was hand-drawn meticulously and put together before and turns into something completely procedurally generated after. And look at how cool that is. That is all generated from an artificial intelligence. That is going to free up the game designer to work on the really fun parts of the story. And it looks absolutely stunning. And even though these AI models are hard to train in the first place and you need lots of data, running them isn't such a big deal. This is actually running on a consumer Intel-based PC with an RTX graphics card.
Everything since that fallen tree has been built using our brand new experimental suite of procedural content generation. And the cool thing is that it communicates with other nearby procedural elements in the scene, like the creek bed. So let's say a designer comes by, wants to direct the player to drive to the left. Jacob can simply move the assembly to the right, and everything updates to accommodate that change.